In many questions, such as elevator questions or rocket questions, where there is an acceleration, we will often be asked about the apparent weight, and that is often the problem. In many elevator or rocket questions, there will often be an acceleration produced by the engine, where we must then calculate the apparent weight and the actual weight of the individual. So how do we do that? First of all, we'll get our vocabulary in line here. So whenever you're asked the apparent weight, what they're really asking you is the normal force. It is notable to say that does not mean it is a net force. One may be tempted to think, well, it's the apparent weight acting on the individual, so that sounds like a net force, but no, it's the apparent weight, and that is the normal force. So when we use a formula, the net force equals to the normal force plus the force of gravity. It's negative because it's acting in the opposite direction to a normal force. One is up, one is down in the vertical direction. Then we want to actually isolate the normal force because the normal force is our apparent weight. So then that would be F net minus, okay. And to expand the net force, we know that is mass times acceleration, and then the force of gravity will be mg. As I've already explained, the sign convention is like this because I've already incorporated the fact that it's going to be negative here. We've got negative, negative, so it's going to be positive here. Now, the next step, we need to be careful. This acceleration says it's 19.6 ms squared down. So because it's acting down, it's in the same direction as gravity. And according to our reference coordinates, we can say up is positive and down is negative, because we've already stated gravity is negative in our case. So then what we need to do here is when we insert the acceleration of a rocket or elevator, we want to make sure our sign convention is in the same direction as gravity, whatever you set that to be. And I don't need to add negative 9.8 because I've already incorporated the idea of that in here, and it ended up canceling out to be a positive. So if we put that into our calculator, we will get negative 979 newtons as the apparent weight. So there you have the apparent weight. Sometimes a question will also ask, what is the true weight or the actual weight? The actual weight will always just be the force of gravity acting on the mass, which is mg. So then your actual or true weight will be right here.